All right, so this is Unit 2, the atmosphere. For day 3 of class, we'll talk about the greenhouse effect and our Goldilocks principle. Learning targets for this is ES2.C, or greenhouse effect and Goldilocks principle. We'll be able to explain and draw a diagram of our greenhouse effect, describe the importance of the greenhouse effect, identify why Earth is able to maintain a comfortable atmosphere for life, and compare Earth's atmosphere to the atmospheres of Mercury, Venus, and Mars. So how a greenhouse works. Our sun gives off short wavelengths of light. So those can enter through the glass. This is going to heat up the floor of our greenhouse. The floor then gives off heat as long wavelengths of light which cannot pass through the glass. In other words, the heat is going to get trapped inside of the greenhouse. This can keep a glass house warm all year round. So our Earth's atmosphere acts just like the glass in a greenhouse. This is known as our greenhouse effect. It's important to remember that the greenhouse effect is not a bad thing. Without it, life as we know it could not exist on Earth. So part of your notes is to draw a simple greenhouse effect diagram. This is what you can do. Okay, so in your note, you're going to draw sun, and you're going to draw a wavy line, but you're going to make sure that the wavelength is short. In other words, your little curves are very close together. They come through the atmosphere of the Earth. Then the Earth, the surface gets heated up, and they're going to give off long wavelengths. So in other words, our curves are very spread out. And some of them are going to bounce back inside of our atmosphere. So this is life's cozy atmosphere blanket. So remember that Earth is in the Goldilocks zone of our solar system, allowing for water to exist in all states. Water vapor is one of our top greenhouse gases, or one of the gases that helps to trap heat on the planet. So Earth's strong magnetosphere helps to protect our atmosphere from the outside. In other words, our strong magnetosphere keeps the solar winds from blowing all of our atmosphere away. And then our greenhouse effect keeps us warm on the inside. This is what makes it perfect for life. So when we compare Earth to other nearby planetary bodies, okay, so here's Earth. Our atmosphere is 78% nitrogen, 21% oxygen, and 1% trace gases. Water is in all states, so we find it as a solid, a liquid, and a gas. On the moon, we have no atmosphere. Is there water? Maybe. On Mercury, there is no atmosphere. There is ice that we can find at the North Pole. Venus has a very dense atmosphere that is 95% carbon dioxide. There is water vapor present. And Mars has a very thin atmosphere, which is 95% carbon dioxide, and there is ice present. So when we look at this graph, we have Venus, Mars, and Earth. These are the percentages of our gases that are found. Our carbon dioxide is red, nitrogen is green, and oxygen is blue. So when we look at Venus, you can see the majority of it is carbon dioxide with a very small amount of nitrogen. Mars is the same way. It is mostly carbon dioxide, and again, with a small amount of nitrogen. However, when we look at Earth, the majority of it is nitrogen with a good amount of oxygen. Now remember, we do have carbon dioxide present in our atmosphere, but this is less than 1%. So there is a little teeny red line here that you can barely see. So specifically looking at Venus, okay, it's about the same size as Earth, about the same density, and it's made of basically the same materials as Earth. However, now our atmosphere started out similar, but they're now very different. It's termed our runaway greenhouse effect. Okay, so the greenhouse effect happened on Venus as well. However, carbon dioxide, a greenhouse gas, began our greenhouse effect. All the liquid water on Venus's surface evaporated, which is an even stronger greenhouse gas. And this began to get so hot that even our carbon trapped in rocks added into the atmosphere, which is going to make even more carbon dioxide. So now Venus is actually the hottest planet in our solar system, even though it isn't the closest to the sun. And it's just basically because the atmosphere got so clogged up with carbon dioxide that absolutely no heat could escape. So any heat that got to the surface stays there. So on Earth, you can see our incoming sunlight. Some of it gets reflected by clouds, but a majority of it makes to the surface. Some of it, as it goes back out, is able to be trapped, and some of it does escape into space. This is what gives us our perfect little cozy blanket. Now, over on the left side, we have Venus. Okay, so this is our incoming sunlight. Yes, some is reflected because of all the clouds, but whatever makes it to the surface, the majority of it stays at the surface. You have a very small amount that is able to escape. So when we look at Earth and Mars, Mars's atmosphere is composed mostly of carbon dioxide. However, we have a very low gravity. Look at the size difference of Mars. Mars is very small compared to Earth. So it's very hard for Mars to even hold an atmosphere towards its surface. Mars may have once had an oxygen-rich atmosphere similar to ours. However, our once thicker atmosphere escaped because the solar wind pretty much blew it away. Remember, Mars does not have a magnetosphere like Earth does. So the solar wind blew most of the atmosphere away. Plus, Mars's smaller size means it has a very low gravity, so it's not able to hold on to an atmosphere to begin with. So when we look at facts about Mars, it has about 1/10 of the mass of Earth, so about 1/10 of the gravity on Earth. So when we look at before, this is probably what we thought it looked like before on Mars. A nice atmosphere, probably filled with oxygen, just like here on Earth. However, because there's no magnetosphere on the planet, it's mostly been blown away. So they've lost that atmosphere blanket. Okay. When we look at the layers, they do have a troposphere on Mars. Okay. You have water ice clouds. You also have carbon dioxide ice clouds. And once you get up to a certain height, it just kind of keeps increasing in temperature. So there's a stratosphere, but then it pretty much just keeps increasing. Okay.